everyone, my name is Lucky Chedopoli, and today I will be introducing you to complex numbers. To start off, real numbers are any number, positive or negative, whole numbers, decimals, rational or irrational. But now, what if I were to tell you there are also imaginary numbers? So, what are imaginary numbers? An imaginary number is a complex number that can be written as a real number multiplied by I, the unit imaginary number, like 1 for real numbers, and that's known as I, which is the square root of -1, and defined by its property I squared equals -1. For a more in-depth explanation about imaginary numbers, check out my other video. When we combine a real number and an imaginary number, we get a complex number. However, it is important that you know that either part can value 0. So all real numbers and imaginary numbers can also be defined as complex numbers. So let's make a sort of table to further explain this. So I'll label this complex number, real part, and imaginary part. So for example, 5i plus 10. The real part would be 10, and the imaginary part would be 5i, obviously. So, yeah, this is complex. Now, let's take the complex number 15. So, the real part would be 15, and the imaginary part would be 0 because there is no imaginary part. Therefore, since there's only a real part, this number is only real. Now, let's take the complex number 2i. So, as we can see, there is no real part in this complex number, but the imaginary part is 2. And since there's only an imaginary part, this is only imaginary. Therefore, this complex number is only imaginary. Now, can we add complex numbers together? Why, yes. We can do this by adding like terms. So, let's take an example. Say 5 plus 5i plus 10 plus 3i. So we're adding these two complex numbers together. To do this, we would need to add the real numbers together and the imaginary numbers together separately. This would simply be 5 plus 5i plus 10 plus 3i. Here, we can take the like terms, so 5 plus 10 equals 15, and 5i plus 3i equals 8i. So that would just be 15 plus 8i. So here we can just take the like terms, and since 5 plus 10 equals 15, and 5i plus 3i equals 8i. If we add the complex numbers 5 plus 5i and 10 plus 3i, we would get 15 plus 8i. Now let's take another example. Say 5 plus 3i plus 4 minus I. So to solve this, we would once again need to add like terms. So we would need to add the real numbers together and the imaginary numbers together separately. So this would equal 5 plus 3i plus 4 minus I, which would be, since 5 plus 4 is 9, 9, and 3i minus I, that would be 2i. So the complex numbers 5 plus 3i plus 4 minus I would equal the complex number 9 plus 2i. So can we multiply complex numbers? Why, yes. In this case, each part of the first complex number gets multiplied by each part of the second complex number. So let's take an example. Say 2 plus 3i times 4 plus 5i. So for this example, let's use a box method. So let's do 2, 3i, 4, and 5i. So we know that 4 times 2 is 8. 4 times 3i would be 12i. 2 times 5i would be 10i. And 5i plus times 3i would be 15i squared. Now let's add up all our terms. So 8 plus 12i plus 10i plus 15i squared. That would equal to 8 plus, since 12i plus 10i would be 22i plus 15i squared. However, we also know that I squared equals -1. If you don't, check out my previous video. So this could equal 15 times -1. So this equation would be 8 plus 22i plus -15. And finally, since 8 minus 15 is -7, we would get the final solution as -7 plus 22i. So we know that 2 plus 3i times 4 plus 5i equals the complex number -7 plus 22i. Thank you for watching my presentation about complex numbers and how to apply them to problems. Hopefully you have a better sense about the true meaning of these types of numbers and applications in real world. Bye!